let's restart this. Oh gosh, I just slapped my virtual machine. Hey, cancel this darn thing. Okay. Okay, that's not a great thing. Oh, come on. Okay, happy. Okay. Okay, so what we did is we just took this SAR agent based calibration. We went to the main class, and I added a parameter called count cumulative infections. That's an int with initial value 0. Initial value 0 is important. Okay, folks, we want to accumulate the total number of infections that have taken place over time. And we're going to display them in a histogram at the end. So a histogram is going to show for different realizations how many people cumulatively got infected. Okay, so tell me what sort of things would affect. So if we want to keep track in a bookkeeping sense of the total number of infections that have taken place yet, where would we do that?
Should we increment it every time a person?
Good. So I hear someone thinking mechanically, and that's exactly what we want to do. So you want to go there. Every time someone has gotten infected, we want to increment the variable, okay? So when they've gotten infected, how do we refer to that variable? Where does that variable live? Main dot count cumulative infections, and how do we say increment it? Plus. Wow, you folks are getting good. Okay. So here we have a little variable. Let's see if it seems to be working in terms of the simulation. Let's go up to simulation and do run. And this is just a simulation, and I'm going to run this thing out. And okay, I went to oh, you don't have do you have simulation? No? Oh, okay. Okay, do new experiment and just call it normal simulation. You know, call it simulation. You know. And then that will run the model once, and so we'll get to see what it is. And because it will run the model once, we can actually go in and look at what this is. Let's run it, and it says there's 10,000 people infected. Oh boy, everyone infected. Okay, and this time I say everyone because we are in a space of 10,000 people. So we have parameters, total population 10,000. Okay, great. So that's good. So it runs for a single time. Okay, now let's go down to simulation. To Monte Carlo 2D histogram. This is the parameter variation experiment. Now we're going to want to accumulate data in a place that can be presented in a histogram. Okay. Now this is new territory for us. So I'd like you to go to analysis and tell me if you see something having to do with histograms we could drag in here. Anyone? Hello? Yeah? Histogram data. Histogram 2D is the 2D histogram we already had. So this would be histogram cumulative infections. Okay? And we're putting in the experiment. That's right, because it's going to accumulate across multiple particular runs of this model. Okay, I called it. I called it histogram cumulative infections. Okay. Okay. The next thing we want to do is we want to hitch it up so that it gets the appropriate value in it. Where is it going to get the value? Whence will it get its value? Yeah, when it runs the simulation. So remember, experiment runs the simulations multiple times. We're going to create a histogram across multiple realizations of what the value is. So we need to go and for each run of main, we have to get that value and stick it in there, okay? Now, before the experiment run, we should really clear it, just in case there's anything there already. So up before each experiment run, we should put histogram cumulative infections dot reset to clear it. Okay? So this is before each experiment run. So this histogram cumulative realizations dot reset is before each experiment run. Okay? And then, what do we need to do after each simulation run? After we've run main, what do we have to get out of main? The count of, the value of, exactly. And whither does that go? So where does that get placed? Okay, it's in main. That's whence it came, but then whither does it go? It actually goes into the histogram cumulative infections. So it actually goes into that. We have to add it to that. We have to add the value we take out of that particular value. So count cumulative infections. Okay, we've added this. So what is root here? Can anyone remind me what root is? A most peculiar name to a non-computer scientist. But what does this represent? Well, what is root? Yeah, it's referring to main. It's referring to the main class. Main class is about to disappear. Before it disappears, we extract from it the count of cumulative infections, and we add it to our histogram. Okay? Right. We want to add the value to the histogram, adding it into the set of data to be used for the histogram. So histogram cumulative infections, we're saying, hey, you histogram, add this value to the set of data you're considering. And what's this value? It's root cumulative infections, the value taken from the main class that's about to be destroyed. Does that make sense? Okay. So that's almost all that we want, but we want one more thing. We actually want to create a graph of it. We want to create a histogram. Among other things, will help us know if it's working correctly. So let's go drag from histogram. There's certainly, it might not ensure that it's working correctly, but it will help us spot places where it's obviously not working correctly. So we want to create a graph called a histogram here under the palette. That graph is associated with analysis, and it's called histogram. And we want to add that in, and we want to call it, count. Well, I call this other thing histogram cumulative infections. I should have called it histogram data cumulative infections, but time is short, and I'm not going to go back and screw people up with that. So this will be called chart histogram cumulative infections. That's the name of the chart. And I'd like to add the histogram data in there. What histogram data do I wish to add in? It's the name of that data set we created, the histogram cumulative infections, the histogram data set. Okay? And this will be called cumulative infections at end of run, or something like that. You don't have to call it that, but that's basically what it's called. Okay? So I added this. It's a histogram. The other thing was the histogram data. We were just accumulating data. This is actually going to display the histogram. Does that make sense? And the histogram has to be told about the data to display from it. Is that okay? People okay with that? Okay. Should we go run? Let's go build it, and let's go run it. Monte Carlo 2D histogram. Okay, that's great. But then, so it's accumulating, but where's our, oh, look at that, we can't drag it. Look at that. See that? Oh my gosh, look at that. Oh, my file already is outputting all the realization data. And I didn't lift a finger. Look at that. Huh. Well, that's weird. Looks to me like, okay, I got to find out where that's being done. What's that? Yeah. So actually, the reason is that it's not letting us scroll over is it probably is disabled. If you scroll down the experiments, you see it says it hasn't enabled panning. You can go down in this thing and it's disabled panning. So we want to enable panning in the experiment so we can pan over. That's what's called dragging it over. Can we try running it now? Let's go try running it. Okay, and there it is. Look at that. Okay, so that's the histogram of outcomes across all different realizations. We had quite a few where everyone was infected. A fair number, about 30%, where very, very few people were infected, and then there's kind of a number short of full infection. Not many in between. Does what we've done make sense? Can I rehearse just what we did? Just recap? Okay. The clock suddenly got fixed. Oh, okay. Wow. Okay. Right. That's great. I was thinking maybe it's right twice a day, right? Talk about realizations and uncertainty. Okay, so let's rehearse what we did. The first thing we did is we took this model, we added a parameter to main to accumulate the count of cumulative infections, and we modified the agents such that when they got infected, they would increment the count of cumulative infections, just so that when they got infected, it would sort of increment it so they know it's one more infection, right? Okay, now that parameter, where did that live? It lives in main. So if you run the model to its end, that parameter will hold the count of cumulative infections to the end of the model. And that's what we took advantage of. So in this Monte Carlo histogram, we went and we added in a histogram data object to accumulate our histogram data. We added in a chart to display that cumulative histogram data. And we added in a bit of code that would, go and when the experiment first started, it would make sure that the histogram data was clear. And then when main finished running, each time main finished running, it would go add in the value from that variable in main that we had added. It would add it in to this histogram data. And this chart took care of, in its natural declarative way in any logic, it took care of displaying this histogram data that we added. So that over time, while we ran this, this is being updated. As it's running, it's reporting how many different realizations met with different characteristics. So we just rehearsed the basic steps for accumulating parameter variation data. And really, ladies and gentlemen, that's the difficulty. That's about the extent of the difficulty with adding a parameter variation experiment. You add it, it's no problem. I mean, watch this. You want to add a parameter variation experiment to a model? Let's add it to a, okay, fine. I'll add it to this, to one of these models we made in our class. I'll add it to this model that I'll add it to the budding model. There we go. We're going to add a parameterization experiment to this. Experiment and parameter variation. Okay? There we go. Boom, done. Okay, yeah, that's all well and good, and we can use it to set the, well, there's no parameters. Okay, great. But we could run it again and again and again. It's just system dynamics model. But the real key is, what do you fill in here? And we just rehearsed that. What do you fill in here? Well, basically, you're going to zero out any data you're accumulating, and then after each simulation run, you're going to accumulate the data you want to present, and we've shown how we can present it, like in a histogram. That's basically what there is for dealing with new parameter variation experiments. It's nothing terribly complex. Does that make sense? Any questions on that? This learning is going to feed directly into tomorrow's discussion of calibration, because a calibration experiment, like a parameter variation experiment, runs the main many, many, many times, and for each one, it reads data out of it and compares the data generated by main to the empirical data. So it's the same basic process. So this foundation that we've built this afternoon, this edifice, we're going to build atop it tomorrow. Okay? We're also going to build atop the sort of whole thing about adding in things like histograms and getting output data, adding in those variables to collect some sort of data. If I have my druthers, that wouldn't be something you have to do, you have to fix in the model. It'd be something you could flexibly add to the model or remove from the model. And if Priesri has her way in her thesis, if she succeeds in her thesis plans, then that process will be a lot simpler. But for right now, you have to add those variables in and get it to rig up the mechanisms to observe that data. Okay? So any questions before we begin the Java tutorials?
Yes. When you talk to the folks at Finalizing, the development people,
yes.
Where are they? Are they in St. Petersburg or are they in Chicago?
They have been in St. Petersburg. I know that they're in the midst of transitioning a lot to Chicago, and I believe over time they'll be increasingly in Chicago.
I mean, so they're moving their developers from St. Petersburg?
That's my understanding, that many of their developers will be moving from St. Petersburg in the fullness of time.
Just envisioning talking to them myself.
Yeah.
Well, and we've reached out for help, and they were responsive for a while with the time delay, and then all of a sudden we were getting responses from people in Chicago. It was kind of weird, right?
So I want to highlight, if you want clarification on things, I provided you with a link to the forum that we've created, where RTAs will be on it, etc. And
even better. And
that would be in closer time zones.
Yeah.
Although not necessarily closer climatic zones. Okay. Yeah, that's right. Okay. Okay. Any other questions? Okay. So let's transition into our mode for Java tutorials. Right? Okay. Great. Thank you, everyone.